Hi, dear friends and wonderful viewers. It's a pleasure to have you with me on this channel once again. In this video, we are going to take a look at the introduction to quantum mechanics. So, we seek to have an insight into what quantum mechanics is and the features of quantum mechanics, the origin and the originators of quantum mechanics, the interpretations of quantum mechanics, the contrast between quantum mechanics and classical physics, and then, of course, the success and failure of quantum mechanics. Now, quantum mechanics is one of the two pillars of modern physics. The second pillar being the theory of relativity. Now, quantum mechanics is a theory that tries to describe or explain the behavior of matter at the atomic and at the subatomic level. As we know, classical physics, which was developed from the ancient time up to 1900, was fairly good in explaining reality from the macroscopic level up to a few microscopic scale. However, with the turn of the 20th century, the attempt to apply classical mechanics to explain the world of atoms and the subatomic particles, significant challenges were met because classical mechanics was unable to explain the behavior of atoms and subatomic particles. So there was a need to create a new theory to explain the observed discrepancies, and this gave birth to the origin of quantum mechanics. Now, notable originators of quantum mechanics include Max Planck, Niels Bohr, Paul Dirac, Erwin Schrödinger, Heisenberg, Max Born, David Hilbert, and so on and so forth. There are so many names, so many scientists that were involved, scientists of the earlier 20th century that were involved in the creation of quantum mechanics. Now, the contrast between quantum mechanics and classical mechanics rests mainly on the following aspects. The first aspect is what we call quantization. Now, in quantum mechanics, the main variables or quantities or physical quantities are energy, momentum, angular momentum, are observed to be quantized. And by quantization, we mean that these variables they do take discrete values. They take discrete values, unlike in classical mechanics, where the physical quantities can have continuous values. They can have continuous range of values. In quantum mechanics, the physical quantities such as energy, momentum, both angular momentum and linear momentum, these variables, they take on discrete values, and hence the technical term for it is to say that these variables are quantized. Now, another point of departure or difference between classical mechanics and quantum mechanics lies in its applicability. Classical mechanics is able to explain phenomena at the macroscopic level. The normal sized objects, classical mechanics were able to offer a good explanation to the reality we perceive. However, they are inadequate. They are inadequate to explain the behavior of the world of atoms and the subatomic particles. So quantum mechanics did a very good job in explaining the world of atoms. Another difference between quantum mechanics and classical mechanics rests on the fact of measurement. Now, in measurement, in quantum mechanics, measurements tends to be uncertain. They are probabilistic. The quantum mechanics tends to show some degree of uncertainty or probability, unlike what we have in classical mechanics, where measurement tends to be certain and deterministic. So we can say that classical mechanics are deterministic theory, while quantum mechanics tends to be an undeterministic theory. Thank you.